Good day, everyone. In this video, we are talking about exponential functions. In this video, we will cover A-net misconceptions, law of exponents, rational exponents, exponential graph characteristics, and exponential transformations. Now, the law of exponents and the rational exponents, this is me discussing it with the class for the homework that was already assigned. So we may not have the exact slides of law of exponents, rational exponents, right? So if you are at the house watching this, you may just need to just have those notes handy of the homework that you did, such as whatever, and we get ready and do this. All right. Now, if you're at home, I may assign something a little bit different for you to get a review of law of exponents and rational exponents. Announcements. Tea time with the Howard. Let's have the tea. Spill the tea. What's the tea? Here's the tea, y'all. Check Google Classroom, that is, and the calendar for important information. I will tell you, but I will only tell you information once. Please look at the information that's always in the classroom and the Google Classroom. Make sure you adhere to all participation guidelines. Many of you guys lose points on using your phones inappropriately and not really doing anything other than just, hey, what's the answer? That's not gonna give you a whole lot of participation points. It's gonna give you few, if not any. You may get a zero, depending on how I feel about it. Sixth period is awarded 10 bonus points added to their quiz grade because sixth period had the best participation. In that classroom, you had the best teamwork, the best explanations. You had a lot of good things going on sixth period. So right now, I'm impressed with sixth period. All right. Start registering for the ACT for April. It is a grade. Remember, as I told you guys before, your ACT that you have taken this school year, to have that score recorded. I cannot have any scores past then. So remember, ACT is required from the 2022-2023 school year. I want nothing past, years prior. So if you score 18, 21, 22, well, that can't count because it wasn't in the school year. I know, hey, but I got 18. That's cool, fine, dandy, whatever, but no. All right? March 7th is the ACT for the school. It is a grade too, so please be here. Be present. All right? March 7th is the online ACT. So we will be taking it online for the school, and Desmos is allowed. Desmos is the calculator. So please adhere to all Desmos skills that we have did so far. All right, ain't that misconception? I mainly want to talk to you guys about the whole thing because the ANET was a bit mess because again you guys had a 2 week break and it was like how can you retain a whole lot if you wasn't around for 2 weeks and they test you guys as when we came back. That was kind of stupid on their part, but it's all right. All right. So look, one of the things I wanted to address to you guys about real numbers, complex, and imaginary numbers, because we did talk about this at length. I was suspecting you guys to at least get this right, but a nice number of you guys missed the mark on this. All right. So remember, if it's imaginary, I mean it has an I attached to it. Even if it has a number in front of it, it's still imaginary. Complex numbers are real and imaginary. So they could be written as real number plus an imaginary number, or or a real number plus a negative square root. And we know any number that has a negative square root is a complex number, like 2i. So I don't know why they got negative 2i, but let me do negative 15 in the square root. So when you write that, you gotta write this as I, comma 15. I usually prefer to do 15i, but however, on the ACT, they won't tolerate that answer. So put the I in front always. Now if it's the square root of negative 4, you could rewrite that as 2i, because square root of 4 is 2. So I will be teaching you the ACT way of things. All right? And remember, the square root of negative 1 is I. Anything has a negative in the square root is I. I squared is negative 1, which makes it a real number. So keep those things in mind. And pause the screen if you need to just write down notes. Let's just keep this up, all right? So let's move on. So which one? On ANET, they had a question that looks like this. So it was either real complex or imaginary numbers. Now ANET, they said some numbers could be in two categories. So let's do the first one. Negative 5 plus 2i. Mathematically speaking, the answer would be complex. Although ANET, they say something about it being an imaginary number as well because they're 2i, but mathematicians and on the ACT for sure, they consider that to be a complex number. An imaginary number is just a number attached to an I or a negative square root. So negative pi over 3, real, complex, or imaginary? It's a real number because you could see that on the graph. Imaginary numbers you can't see on the graph because pi over 3, that can be a number that crosses the x-intercept. Remember, anything that is imaginary does not crosses the x-intercept. All right, what about the square root of negative 4? That's purely imaginary because square root of negative 4 is just 2i because that negative sign is just I. All right, I squared, real, complex, imaginary. It's a real number. What about 3i? Well, because it has a I attached to the number, it's purely just imaginary. Again, I do understand how some of you guys made those choices because I pretty much went over the ANET, but some of the information that ANET was telling you is not correct. But the black check marks is something that you definitely have to understand when you take the ACT. Right? We're back into the fray. So yeah, complex numbers have to be worked out like this. So on ANET, some of you guys, after going over it right before you took ANET, you got these kind of problems wrong. So let's talk about it. So complex numbers are written as the real number plus the imaginary number. Now look, this particular notation, which is new to you guys, this is just saying A is in the real numbers, which is true because A is a real number. So again, AER, what backwards E, A is in the reals. Like for example, if I was to say 7, 7 is in the integers. 1/3 is in the rationals. Right? So let's erase and move on and solve some of these problems. The stuff I just erased, I will be questioning you about this, so make sure you got all your notes together on this. So let's do this. So you got this first problem. How are we going to solve it? Well, a problem like this is just, again, combine your terms. So you should actually pause this and try this, because when you get tested for these things, you actually have to know it. It is not beneficial for you to just copy down everything that is being said or written to you. Try it out on your own. See what you can do. Pause the video. All right. Pause the video now, please. All right. From that, you should be able to have your work together. You should have checked it. You should have some idea what to do, because we did this before. All right, so let's go through it. So what I'm going to show you is a similar way of doing these kind of problems, but I'm going to show you a different trick to it. So I don't know about you guys, I like to stack. Sometimes stacking helps me make things easier for me, because it's plus 2 minus 3i. So when I'm stacking, I can put things together. 3 plus 2 is 5. 5 minus 3 is positive 2i. And I should have my answer. Bam! My answer is correct. All you have to do is just that. Alright, I want you to pause again for the second problem if you have not worked it out already. And come back once it's done. Alright, welcome back. By now you should have had it worked out, figured out. I'm going to show you another method of solving this problem. Because when we solve problems like this, we should use our foiling method. Well, you don't have to use foiling method. What if you go by stacking again, as we did in the previous problem? Stacking sometimes help. So why don't you do this? 2, because you're taking 2 times 3 plus 4i, because that's pretty much all you're doing. That's foilings. So let's do it. So you could draw the arrows here, but I won't personally need to draw arrows, because I know a number in front of the parentheses means to multiply. So 2 times 3 is 6. 2 times 4 is 8. But remember, because you have an I, 8i. Alright? So let's stack the second one. So the second one is negative 7i. It's going to be right here. Negative 7i times 3 plus, right, my plus sign is too far away, plus 4i. Okay, y'all ready? I'm not drawing the arrows for this part because I know a number outside the parentheses means multiplication. So negative 7 times 3 is, well, negative 7i times 3 is negative 21i. Okay? Negative 7i plus 4i is negative 28i squared. Alright? So I know that I squared is negative 1. So this negative 28i squared, I could rewrite it as negative 28i squared could be rewritten as negative 28 times negative 1, which gives me a positive 28. Alright? So now that negative 28i squared, I could rewrite this. I'm only erasing to let you know that I just rewrote it. Alright? You still need to keep the original negative 28i, but I'm doing this so I can know for a fact that negative 28i squared becomes positive 28. Alright, so let's go ahead and put things together. So we got a 6 and a 28 that we could add together. And when we do that, we get 34. Oh, so that's 34. Let me erase. That's for some of you guys. Handwriting is so important. Alright? 8i minus 21i. That's going to be negative 13i. And let me fix my 3 because it looks like a B. I want that to be seen. Alright. And there we have it. Please know what you're doing. Because when you get quizzed on this, you need to have this figured out by science. I may ask you something more difficult than this. So when you take your quiz, it may not be those exact problems. I may put a bunch of letters and have you to, figure this out on your own, which you will do on your own anyway. But for the quiz purposes, know this well because I'm going to ask you a question that involves only letters. All right, law of exponents. A day, students who are present in the classroom, let's review the homework. B day, review the Kahoot. And again, this is for in class, so if you're watching online, there's some assignments that you can do to review law of exponents. All right, now let's talk about exponential graphs, dealing with the characteristics of domain, range, y-intercept, and asymptote. So guys, an exponential function is a function that says if b is any number such as b is greater than 0 and b not equal to 1, then the exponential function is in the form of f of x equals b's of x. So guys, in decimals, f of x is just saying y equals b of x. Alright? Well, b is called the base and x could be any real number. So x is what? X is just the exponent, y'all. So it's not really too hard. All right. So let's get to a further detail. So when you put this in decimals, depending on how you've written it, f of x equals b of x, y equals bx, they're the same thing. Remember, f of x equals y. They're the same exact thing. Or equivalent. There we go. Same exact thing. So when you put this in decimals, you should have a graph that looks like this. But let's move on. All right. One of the important characteristics that we need to know of is the asymptote. Now, I personally paraphrase what an asymptote is. It's when the graph gets close to a specific value as it takes forever to touch. So in terms of the exponential functions, we're going to be dealing with the horizontal asymptote. The reason why we are dealing with the horizontal asymptote because we are dealing with mainly the y-axis. We are dealing with the y-axis. So y'all, it's a horizontal asymptote when x goes to infinity, or negative infinity when your curve approaches some constant value b. So exactly what I just said. So again, it looks something like this. This is the graph. This is the the x value. Okay? At some point, it's going to touch, but it's going to take forever for it to touch. It's going to stay on top of it for a long time, and then at some point it will touch. But for the time being, that's not the case. All right? That's what we were looking for. The y and the x. All right, let's get ready and move on. So, I have something like this. Put this in decimals for me, exactly as you see it. So when you put this in and do nothing else but just put exactly what you see, you're going to come across a message like this that says add slider. Remember what the definition tells you. B, which is the base, has to be greater it has to be greater than 1 in terms of decimals. So look, when B is 1, it's just a flat line. That's not the graph that we need. But if we may be greater than 1, that's the graph we need to see. So keep this in mind when you put in the exponential function. Make sure that your b is greater than 1. If it's less than 1, such as 0, it's going to be undefined. If it's 0, it is undefined. If the 0 is undefined, you won't have a graph. Keep that in mind. All right? So remember, b cannot equal 1 because you get this flat line and that's not our graph. But it has to be greater than 1 so we can get the graph we need. Moving on. So let's do the characteristics. Now since we know how to put the function in. So put in y equals b of x and make the slider greater than 1. 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 And you should have this graph look exactly like this. So let's talk about the characteristics of this. So the domain, and the domain is all the x values. So remember, going back to your early Algebra 1 days, domain is all your x values. As you can see, when you're going through your decimals graph, it comes from a very, very small negative number. It does not have a starting point because you keep going left, you're going to see the graph. And then when you keep going to the right, the graph keeps going. So it's positive infinity. So therefore it's all real numbers. Negative infinity, positive infinity. There's no way of saying all real numbers. Negative infinity to positive infinity is saying all real numbers. Negative infinity to positive infinity is saying what? All real numbers. Alright, so let's talk about the range. The range is all the y values. So when the graph starts at y. So we look at this graph, it starts off, when we see the graph as some zero value, at 0. But if we scroll up, the graph keeps going, so it's positive infinity. And because you're dealing with arranged like that is going to be with the parentheses. All right? So the asymptote of this, again, you're looking at the y equals 0. And I know this is a thing that many people don't understand, so let me draw some lines on the y-axis, through the y-axis. So draw horizontal lines because in this lesson you were dealing with a horizontal asymptote. So let's look at 10. So if I draw a line at 10, the graph touches. If I draw a line at 8, the graph touches. If I draw a line at 6, the line touches. If I draw it at 4, the line touches. At 1, the line touches. But at 0, it looks like it's touching, but it doesn't. But it will later on, like down far, far away the line. So the asymptote is 0 because it, when we draw the line at 0, it approaches 0, but it doesn't touch it immediately. You cannot say -1 because the graph is not even near it. The graph is not near -1. You can't say -2 because it's not even near -2. It's near 0, but doesn't touch 0 for a good minute. So let's figure out my y-intercept. My y-intercept is 1 because it touches the y-axis at +1. So you can write it as 1, or you can write it as a coordinate 0, 1. So that's pretty much it. You're just applying those 1, 2, 3, 4 things throughout these functions. So now keep your decimals on and let's get through this. Initial graphs and transformation. How the graph move. Now, there's going to be a critical question that I'm going to ask of you later on. How does the transformation the transformation affect the characteristics? Again, in this little segment, the question that you have to keep in mind is how does the transformation affect the characteristic? When you do these transformations, think about the x-intercept. Think about the domain, the y-intercept, domain, range, asymptote. And let's figure out how that transformation affect those characteristics. As I go through this, I'm going to go through this pretty quickly, but I need for you to look at the graphs, and the graphs should be able to tell you your answer about how the transformation affect those characteristics. So look, the transformations that we'll be dealing with is going to, are going to affect characteristics of the exponential function we just had to find out. So look, if I'm looking for k, like for example here, k is going to be in the front and back. If it's positive, it's going to go up. But if it's negative, it's going to go down. So what if I have this situation where the number is next to the x, like here? I'll start highlighting this. So here, because it's negative, it's going to go right, it's going to go the opposite direction. Why is that? Why is x x minus 2, why does it go right instead of left? That's something to ponder about. What if it's positive 1? It goes left. So keep those in mind. All right. So what if I have numbers in front, in the very front? If it's a whole number like 6, it stretches. What if, what if I have a fraction in front of it? It's going to compress. All right. So what if I have a negative number in front of it? It's going to reflect across the x-axis. All the other stuff that I did not highlight, it's not important. All right. Those things are not important for this particular function. All right. So best, which graph best represents the function? Put this in decimals and find out. Pause the video while you find out. Okay, welcome back. By putting in decimals, you know the following. You know that the first one best represents the graph because it's going down 5. Just down. Because this tells me it's going down. The second graph, it looks like it went down 5, but it looks like it went to the right by some number. Let's do this one. Which one best represent the function? Put in decimals to find out. All right, and don't forget to pause the video because I ain't telling you till you find out. All right, welcome back. By now you should have known that the answer to this is going to be this guy. So look at it. There's something about this, though. Because it's negative 5, it moves to the right. Why is that? We still got to figure that out. I'll give you a hint. Why don't you not put in decimals? Put this in decimals as you see it. And that should tell you why. We are solving exponential equations with and without decimals. With decimals is easy. Without it, you have to have a good knowledge of your law of exponents. You have to know your laws of exponents. Without those laws of exponents, you're gonna have a hard time doing this by hand. And remember on my quiz and test, well mainly my quiz, you gotta show me by hand. If we was to put this in decimals, we get negative 3. Typing in as is, you get negative 3. Now, for my test purposes, you need to show me how to do this by hand. To do this by hand, you need to do the following. Since your bases are the same, you got 2 as a base there, 2 squared, and then on the other side of the equation, 2 is the base also. And because that's the same, you could get rid of those bases and take the exponents. So 2 equals x plus 5. So let's solve this equation. We know if we was to subtract 5 from both sides, we know that we're left with on the right hand side, we're left with x. But on the left, we get negative 3. And so our final answer is x equals negative 3. So again, because those bases are the same, It's like that. All right. So look, now we're dealing with a situation where the bases are not the same. All right. So when you solve equations, you can put this in decimals, but make sure when you put this in decimals, make sure you surround it by parentheses, especially when you get to this part right here. Let me give you a better marker because I know that's hard to see. Make sure while I just highlighted, you put that in parentheses when you have to hit the exponential key because it won't graph. The x from the left hand side of this, because it's just x, you don't really have to put a parentheses by it. I do it personally just to be on the safe side because the right hand side has a parentheses. And you want to make sure that both sides have something similar, which is parentheses. So decimals corrected. So when you graph it, you get positive 1, and there's x equals positive 1. Now, let's figure out how to do this by hand. Now, on my quiz and test, remember, you got to do this by hand. It's cool. I'll be testing your ability to put this in the calculator, but remember, I'm also going to test you for the skill. All right? So look, let's look at our bases right quick because we're dealing with exponents. So we got a and 2. So can we rewrite 8 as an exponent of 2? The reason why I asked that because you want to look for the small numbers. The small numbers make things a lot easier. You want to take the big base and you want to convert it to a smaller base. Again, you want to take the bigger base and convert that to exactly the small base. And you do this by 2 to what power gives me 8. And all thing you have to do is just put in the calculator. So 2 to the first power does not give me 8. 2 to the first power gives me 2. What about 2 squared? 2 squared gives me 8. I mean, not 8, it gives me 4. 2 cubed gives me 8. All right? So because of we found out that 2 cubed gives me 8, now just rewrite your bases so that they could have the same base. Rewrite and make those bases the same. Guess what? That's it. Now, since the bases are the same, let's get rid of them and solve the equation. So we have that going now. So subtract 2 from both sides. We get x equals 1. Voila. You put in decimals to have your answer. You did the work to make sure your answer is, all right. Now make sure, again, for my quiz, you're going to have to do all of that. All right. What about a problem like this? This one's hard. This one, you're going to have to use your law of exponents. That's the thing about these equations that makes them challenging. You gotta know how to use your law of exponents. To do that, you must do the following. Put it in decimals, exactly as you see it. And when you do that, you get 0.5. All right? Now, let's go ahead and put in the work. So, using your law of exponents, you know that the square root of 5 could be written as 5 to a half power. And from there, get rid of the bases, and you're left with x equals 1 half. And that's it. The climax. Now it's time for you to demonstrate some skill. Check Google for the task and the homework.